day 25, part 3 of inverse functions. So this should be the last part, I believe. Uh, Functions f and g are differentiable functions, and selected values of them in the first derivatives f prime and g prime are shown in the table below. Use the table of values to answer the questions that follow. All right, so for the first question, it says find the value of g inverse of 1, then find the equation of the line tangent to the graph of g inverse of g when x equals 1. All right, so what I want to do first is I just made some mistakes on part 2. I'm going to try to catch those mistakes up front. So I'm going to make a column here, um, g inverse, and it's not based on those x values because I'm going to put the x values in here. Ooh, man, that was awful. So obviously g at -2 is 2, so the inverse will be 2, -2. Here is 0 and -3. Again, I'm using the values of x's and these values of g. Again, to hopefully stop that mistake. So 0, -3. So the inverse of g will be -3, 0. 1, -2. So the inverse will be -2, 1. So when x is -2, we get 1. And lastly, it'll be 1, 3. All right, so what's the value of the derivative of the inverse of g at 1? So we know the inverse of the derivative of an inverse is 1 all over derivative of the original function of, again, composition of functions of the inverse at that value. So now when I look at this, again, inverse g of 1, let's come up here. Again, this is where I made the mistake last time. So now that's going to be 1 over g prime of 3, because that's saying x is 1. So again, I know it's y here, x is 3, but then we took a look at the inverse, and it's going to be 1, 3. And now, let's come up here. Hey, what is, when x is 3, what is um, the value of the derivative? That's going to be -2. Again, that's the x value. Okay, so what did I just find? I just found out that -1/2 is the slope of the tangent line. It's nowhere near what the question's finally asking, saying, hey, tell me what the equation of the line tangent to the graph is. Um, we we just said our value at that point. Where's my cursor here? There we go. The value inverse g of 1 equals 3. So that's our point of tangency. So now this is the equation of the line tangent to the graph of the inverse of g when x equals 1. So there's our point of tangency. So it's going to be y minus 3 equals -1/2 times x minus 1. That's our equation of the line. Perfect. All right, so this next question is going to ask us to estimate the value of g prime of -1. So to estimate, we're going to use the slope of the secant line. What conclusion can be reached about the graph of g when x equals -1? So this derivative, the slope of the secant line is positive. We say it's increasing. If it's negative, we're going to say decreasing. So looking at the table up above, there's my cursor, sorry. So for an estimation, g prime at -1, we're going to use -2 and 0. So hey, we're going to find the y value of g of -2. We subtract that from g of 0. And then obviously, so we're using the slope formula here. Oh, this is an estimation, so it's approximately equal to 2 minus -3 all over, this is -2. So we get 5 over -2. Okay, so we just found, hey, since the derivative is -1, derivative of -1 is a negative value, it's going to be decreasing. Now the next one is our first time talking about second derivatives. That's what that symbol stands for, second derivatives. Well, hey, if I wanted to find the derivative, I looked at the secant line of values of the original function that were a little bit to the left of it and a little bit to the right of it. Well, here I want to do the same thing. So to estimate, I'm going to find the secant line. So when I do g double prime, which again, second derivative, the estimation is going to be a little bit to the left on the derivative, which will be negative 2 again, and then a little bit to the right of the derivative. And once again, we use the slope formula. So now we look at the chart. G prime of negative 2 is 3. G prime of 0 is 2, all over negative 2. Uh, this is going to end up being 1 over negative 2, which is negative 1 half. So same thing, since I know G double prime of negative 1 is less than 0, then, and I'm going to be a little more specific, then the graph of the derivative is decreasing, where I should have up above said the graph of the original function is decreasing. So the same thing we could do with the first derivative and the original function. Hey, that same logic's going to hold true from the second derivative to the first derivative. And that's what we're leading into in the next unit. Okay, that's it for part 3. Um, that's the end of unit 3. We got a few things we have to do and quiz sometime in the next week or so, and then test in a couple weeks coming up.